All right, just to get one more good example in, we'll go ahead and add a third one to kind of our list that's there, kind of doing the same strategies of the example we just did. So once again, we're going to look at our form that we're kind of starting with. Easiest thing might be to do is just kind of match up, see whether our x is the one that's squared or y the one that's squared. We see that our x is squared, match it back up to our forms yesterday, so we're going to see that we have a vertical axis. So let's get it written in terms of that form, in terms of that vertical axis. All right. Now for us on this one, kind of the same idea is going to form once again. We want to try and get all of our x's on one side, all the y's to the other. Now my suggestion would be this though, even though the 9 is a constant, it doesn't have an x or a y with it, let's kind of group that with the y, move all those over to the right hand side, so undo those operations. And when you get there, you'll notice that you have x squared minus 2x equals, undo the positive 8y and the positive 9, so it's going to be minus 8y minus 9. And then just as we saw in the previous one, it's really this squared value that we need to be able to factor as a perfect square. So to factor this as a perfect square, that means that we have to complete the square. So let's walk through those steps one more time. Once again, we're just going to worry about the shortcuts in terms of completing the square, not going back and trying to do a lot of different stuff here. So we've got x squared minus 2x plus, we need to figure out what constant can we add on to this expression so we can complete the square. Quick steps, remember once again, take half of that coefficient of x, which is negative 2, take half of that would be negative 1, multiply it by itself to give us this constant, so negative 1 times itself would be positive 1. But since we added 1 to the left-hand side, we have to stay consistent and add 1 to the other side. So we have to do 8y. We already have the minus 9 here, so I'm going to go ahead and just add 1 to minus 9, so we end up with minus 8. Now let's factor our perfect square. So it's going to factor into the same two expressions, so we're just going to go ahead and square that. And remember the quick step was still use that same variable of x. Quick step was to take that coefficient of x and just take half of it, which would be minus 1. The minus 1 plus itself gives us that negative 2. Multiply by itself gives us the positive 1. And on the right-hand side, we can factor. So let's pull out a common factor between each of the two terms. I'm also going to pull out that negative as well, so I don't have a minus in front of the y. So minus 8 times the quantity y, but our minus 8 times we need a positive 1 to give us that minus 8. Now everything's set up in terms of the form that we've got. Okay? Find our x's, so we know that that's going to be our h value, because we can look at the x's to help us find what the vertex is in that expression, or the x-coordinate of the vertex. Our k is going to be over here, and if we pull off that coefficient or that factor, that negative 8 that we factored out, we want to do just a little bit more work here, because if you match it up with our standard form, we know that the negative 8 equals, it's in that position of the kind of the 4p, which affects the shape of the graph. Simply dividing by 4 on both sides allows us to see that our value of p is negative 2. And if we take the absolute value of that, it just means that that's a distance of 2. So it represents we've got a distance of 2 from our focus to the vertex and a distance of 2 from the vertex to the directrix. Now from here, what we have left to do is still pull off all those different pieces. So I'm going to try and keep a list kind of going right here at first. So the first one we want to find is going to be our vertex. That's kind of always the easiest one to find. So we can pull off our h. Be careful on this one. We just have to pull off 1 for the h. And then also be careful on this one, our k value. Remember, it has to be y minus whatever k is. So the number we have to plug in for k to get y plus 1 would be minus 1. Next one is our directrix. So to find our directrix here, let's pick up with that form that's there. Notice we already figured out that we have a vertical axis. So the directrix is going to be perpendicular to that, so we know it's going to be horizontal. So it's going to take on the form y equals some constant. We pick up from our form that it's as simple as just taking the value of k, which is the y coordinate of the vertex, subtract p, which is going to represent that number that we found in terms of, kind of tells us the distance between the focus and the vertex also. So we'll take negative 1 minus negative 2 becomes plus a positive. So this would simply be at y equals a positive 1. And then our very, very last step that's left for us is simply this. We need to go back and find what our focus is. Quite often the picture is very helpful for the focus. So I'm going to go ahead and label that we need to find the focus. I'm going to come over to the side here. Let's draw a quick little sketch of what we've got up to this point. So if we notice, we can start with our vertex and plot that point, which would be 1, negative 1. I'll label that as a V just to represent our vertex. The second thing we can plot is going to be our directrix. So that's at an equation of y equals 1. So we have to go up 1 on our y-axis. It's a horizontal line, so we're going to plot that horizontal line, which would have an equation y equals 1. And remember that the vertex, that distance is a length of 2 between the vertex and the directrix. We just need to stay consistent here and make sure that the distance between our vertex and the focus is going to be 2 as well. So if we drop down 2 more spaces and put a point directly 2 units below the vertex, that's going to be our focus. So we just need to notice that that order pair would be positive 1, negative 3. So we can add that to our focus, positive 1, negative 3. And if you wanted to, we could draw a quick sketch and notice that our parabola is going to open down.